optimize your code into server components and client components in a way that makes sense and optimizes both the developer experience and the user experience. So what exactly is page architecture? Imagine constructing a building where each piece that you put has a specific function, location, and purpose. A sturdy page architecture similarly places the bulk of the HTML or JSX within the walls of server-side components, essentially, laying a strong foundation for the entire application. What I'm trying to get at here, and this is something that I will be repeating throughout the entire course, is that server components should be the building blocks of your web application. If you're coming from previous versions of Next or just traditional React, you're used to building client-side components and putting all that logic, your business logic, or at least your UI-related logic inside them, and mixing and coupling potentially some aspects of that logic that should not be on the client side. Now with the new version of Next 13, and even now with the latest release of 14, and the incorporation of server components as the default building block when you're creating an application, when you're building new components, we want to shift the bulk of that UI code, we want to shift it into the server, if it makes sense. That way, and we're gonna get into more details in further lessons, you optimize the developer experience by simplifying the way in which you write and you envision the interactivity with the users, and also improving the user experience by providing an optimal and more performant output, by improving metrics related to the speed at which the page is loading. Because as we're going to be looking at in further videos, server components allow for a much faster and much more dynamic rendering of your pages. And coupled with the concept of page architecture, you will be able to properly optimize the way in which you write the code so that the minimum amount of JavaScript gets shipped to the client and as much work as we can do on the server gets done on the server. Here you can see an approximation of what I mean by improving the experience of the user. The main thing that we want to reduce here is not code, because you're still going to be writing probably a similar amount of code, but the amount of that code that gets shipped to the client is significantly reduced when you're using server components, because a lot of that code gets executed and stays in the server. It's no longer shipped to the client where it needs to be executed in order to hydrate the components like we used to before. Now the majority of that code is going to be executed on the server, and we're just going to get the output of that code, essentially the render components. There are many bad practices when it comes to architecting your page now that we have a building block such as the server components. One of them, and is one of the main reasons why I thought about creating this course, is when developers are just faced with blockers trying to use server components and decide to just go with client components for everything. That means you cram every piece of code into your client components, including the code that doesn't really change or require any interactivity from or with the user, essentially. If a piece of code is not doing anything dynamic, essentially updating its data or interacting with a user, then it's definitely something that should not be in a client component. And we'll get into more details about that. But another very common bad practice when it comes to architecting your page is performing data fetching within a client component. Again, this is a very common practice if you come in from previous versions of this technology, but now we have more reliable and easier tools to use. Here is an example of a component that is trying to do everything. It's trying to fetch the data from the API, process it, and also show it. However, there are different ways in which we can solve this by properly architecting our page. One potential solution would be to split that client component into two, a server component and a dynamic client component. The server component is in charge of data fetching. In this case, I'm simply putting a URL there, but I could be performing a database query, for example. The point is that this component is pre-rendered the first time it gets fetched. So that query is executed within the server. The data is received within the server, and the HTML generated is also generated inside the server. You don't see any client-specific code here, and we'll get into that down the line as well. But the point is that this server is performing the data fetching and pre-rendering of the static portion of the component. We then can use this component within a client component, like we see here, and the client component would fetch a pre-rendered version of our profile. So we're no longer adding data fetching code to our client component. We're no longer dependent on an API endpoint that we created within our app simply to perform data fetching. And our client component is slimmer, easier to maintain, and only focused on the interactivity part. In this case, simply adding a button to set a fake editing option. By focusing client components solely on interactivity, we avoid the common pitfalls like mixing presentation code with business logic or coupling data handling with UI transitions. This is something that we want to avoid at all costs. Lean client components mean better maintainability, clearly, less code to write, less code to maintain, and are easier to develop. They just need to focus on one thing. Picture, if you will, if you want to still try to figure out a way to visualize these two type of components, picture a cross-section of a building where each floor is bustling with people going about their day, just doing whatever they're doing. Those are the client components, interacting with users, trying to show dynamic behavior, trying to show dynamic data. Underneath it all, the foundation that keeps the whole building standing, those are the server components, static, never changing, and not requiring any interaction with the users. To wrap it up, a solid page architecture isn't just about performance. It's about creating an application that it's linear, more maintainable, and ready to scale. We avoid the classic pitfalls of bad practices by separating concerns and delivering content thoughtfully, giving the users and developers the best experience possible. So great work so far. We're now equipped to start understanding how to architect our page. We still need to go through other basic concepts before we get to a proper understanding of how these components interact with each other, but we're gonna get there. So in the further modules, we're gonna get deeper into the world of server components and client components, and we'll compare each other to make sure that we understand fully the difference. Specifically in this lesson, we're gonna get into what state is and some of the bad practices around state. So let's get going. So the first thing to understand is that state is essentially the data that represents a specific moment in time of our application. In particular, when you're talking about state in a React application, you can think of it as the memory of your components. It's gonna keep track of your user interactions, data inputs, anything that changes over time in the UI. It's gonna be kept stored within state. And really, state is the key to reactivity. We tend to take for granted the behavior of React when it comes to automatically updating a piece of your UI whenever you update a state variable. But truth is, there's a lot happening behind the curtain to generate that reactivity. You don't really have to think or code anything related to how that piece of your HTML gets updated. However, whenever you use your setter functions for the state, your component is going to be updated. So what happens behind the curtain on a very oversimplified way is that when you call the setter function for your state variable, React will get that signal, understand that you want to update your component, and it will schedule a re-render of your component with a new value of the state variable. Unfortunately, some developers forget about that, or they just don't fully understand the importance of the setter function, and they just tend to skip it when trying to update the state by directly affecting the content of the state variable. However, when that happens, you really are skipping everything on the flow that I mentioned before. You're just updating a local variable. And simply because you're updating a local variable, it doesn't mean that your component has to be re-rendered. So you're skipping all the steps that I mentioned before. Because of that, you're really not achieving that reactivity that you're looking for. Another bad practice when it comes to state management in React is thinking that the state updates that I mentioned are synchronous. Look at this diagram here. There are 3 steps at least, and this is an oversimplified version of it, between you calling the setter function and React re-rendering your component. So that doesn't really feel like a synchronous workflow. Essentially, this sample code here is very exaggerated, but it proves the point. If you were to run this example, and you can do it with the URL shown on the comment there, you will see that whenever you click the button, the value of the state variable clicks is only updated by 1, not by 4, as you would expect if you were to think of state updates as synchronous behavior. This happens because during the execution or during the life cycle of your state at the current moment, the value of the clicks state variable is 0. That's the first execution of it. That's the first time your component is rendered. So it's a 0, which is the default value. And no matter how many times you try to update its value through the setter function, the value of the clicks local variable is always going to be the same, 0. Whenever you call the setter function, you're essentially passing the 0 value plus a 1. It doesn't matter how many times you do it, it's always going to be the same. The value of clicks is going to change only once React finishes the life cycle of all components, gets to yours, understands that there is a state update schedule, performs it, and then re-renders your component. When your component is re-rendered, React is smart enough to understand that this is not the first time the component is being rendered, so it sets the new value to your state variable. And now, on the second render of your component, the value of clicks happens to be 1. And it's going to be 1 again throughout the entire life cycle of your component until a new re-render happens. So keep that in mind. State updates are asynchronous, which means you can't really do what you're seeing here. Another really bad practice when it comes to local state is abusing the local state. Remember that we're saying that every time you update your state, you trigger a re-render of your component. So imagine having multiple instances of local state and triggering multiple updates on them. They would eventually trigger multiple re-renders of your component as well. And that's even worse if you share some of those state variables with child components through props, because whenever that state variable changes, any of those child components is also going to be re-rendered. So if you have multiple ones, then you can definitely generate a performance degradation by creating a bottleneck, essentially, of re-renders within your component. This actually happened to me while I was building an application that had on the left side of the screen a very complex form, which allowed users to input many different types of data, and on the right, a set of generated images based on that data. Because I was not properly thinking about the architecture of my page and my components, I was linking the many essentially local state variable for each input field, and several of those local state variables were also propped into the images components shown on the right side. At the beginning, as you can imagine, there were few images generated, and so the application actually worked perfectly fine. But over time, I started noticing a degradation when the number of images increased. And that was because whenever I was typing something on one of those fields, every time those fields changed, the state variable was updated. And every time the state variable was updated, all my image components were also re-rendered. In the end, I ended up having a completely unusable UI simply because I was inputting data on my input fields. So keep that in mind whenever you're creating a complex UI. Try to isolate the state updates on single components and try to make sure that these components are not coupled through these state updates. Essentially, make sure that the interactivity is isolated and that each component works individually from each other. Another way to solve the problem I mentioned before, which involves in an interdependency essentially of a parent component with a child component through a state variable, will be by doing something we call lifting state up. This is a very oversimplified version of what I was mentioning before, But here we have a component A that has a local state variable that is being propped into the component B. Whenever the local state variable of component A changes, a re-render is going to be triggered, and a re-render is also going to be triggered on component B. So we don't want that. So what we're doing here is, if possible, and if the architecture of your page allows for, since component A and B potentially have the same level, if you think on a hierarchy level of components, you could have the component, the state actually shared between them by uplifting the state into an ancestor component. Essentially, whatever component is using using them both, you can break that coupling between these components by separating them, simplifying them, and also making sure that they use the shared state individually and they are not linked together, and an update on one cascades an update on the other one. So essentially, in this video, we've covered state from many angles. We've addressed the common misconceptions about state that can potentially create bottlenecks and performance inefficiencies. So make sure to keep these lessons in mind whenever we talked about state in further videos, which is going to be quite often, because they're going to be the key to solving any of the other problems that we need to tackle. So next up, on the next video, we'll continue to perfect our approach by introducing more sophisticated ways of sharing state between components.
Thanks for watching. If you want to keep learning, click the link in the description below.